Let us talk about cross-aldol condensation. In case of aldol condensation, we have known that there will be a reaction between two different aldehydes having alpha hydrogens in the presence of a dilute base. So the base usually taken is dilute NaOH, that becomes our base. Okay, and we will be noting that we have taken two aldehydes. We have taken ethanol and we have taken propanol here, having alpha hydrogens. So what are alpha hydrogens? The functional group is a CHO group, right? This is the carbonyl carbon. Besides the carbon, alpha carbon, and we have the alpha hydrogens with it. Okay. In the case of propanol as well, we can see that the CHO, that is the functional group, the carbonyl carbon, next carbon becomes the alpha carbon. And with that we have two hydrogens, so these are the alpha hydrogens. What happens when there is a presence of alpha hydrogen? What is the necessity of it? What base we are using, that is dilute NaOH, OH minus is going to abstract that alpha hydrogen in the first step, forming a carbanion, and that carbanion is going to attack another molecule of aldehyde. So when ethanol and propanol is present in a reaction vessel, we can get a mixture of four products, which will be of less use in a synthetic use, but still we have to learn about that. First thing is, what may be the possibilities? First is that two ethanol molecules can react. Second possibility is two propanol molecules can react. Third possibility is ethanol and propanol can react, where propanol is forming a carbanion and attacking ethanol. In case another possibility is also there, where ethanol is forming carbanion and that is attacking propanol. Okay, so we have to study about all those, and we can surely get four different kinds of products here. And also aldol will be the product, as I have said you. The writing is like ALDOL. Why it is like this? Because you have the aldehyde group, that is CHO group, and also the OH group, that is alcohol group. So we write it in this way, aldol. IUPAC name you can always give it. So let us see what happens when there is a self-condensation between two ethanol molecules. First step, as I have told you, OH minus will abstract an alpha hydrogen, that's this hydrogen, okay, and it will take away H plus, leaving behind the shared pair of electrons, and that's why we are getting a negative charge on this carbon, and that's our carbanion. This carbanion is going to attack another ethanol molecule, as I have said you. Okay. Now this is going to attack the sites which are positive, and as we know that this carbonyl bond, that is the carbon double bond oxygen bond, will be slightly negative on this end towards the oxygen end and slightly positive on the carbon end. So that is going to attack over here. Now you see how I have written the ethanol, CH3, right? C, okay, this H comes downwards, H, and this C is bonded now towards the carbon. As you can see over here, the shared pair of electrons has just moved, and so it's O minus over here. Now in the presence of water, that is going to pick up a H, forming the aldol product. Okay. Similarly, in the case of propanol plus propanol, you will get a similar reaction. You can show me in these two steps. Okay. I'll be telling you about the other two products. Now next, when you can see over here, that is when ethanol is forming a carbanion, what happens we'll just see. We have to take an ethanol molecule as we have taken here. We know that alpha hydrogens over here present, which will be abstracted by OH minus, and thus the formation of carbanion will happen. Now this carbanion is going to attack a different aldehyde. That's why it is cross aldol condensation, we say. Okay, a different aldehyde, that is our propanol, is there with us, and that is going to attack this carbonyl carbon, forming, just you see the carbonyl carbon, the CH2 part is written over here, then CO minus, this H comes downwards over here, and this C is going to form a bond over here. Okay, then again it takes up H plus from water and forming the allyl product. Now this product can be named as an IUPAC system as well as common system. In case of IUPAC system, the carbonyl carbon, or obviously here two functional groups are there, CHO and OH. So take the aldehyde group as a principal functional group and you have to number the carbonyl carbon of it as 1, then 2, right, then 3, then 4 and then 5. Okay, so it gives us 3-hydroxy pentanol. Okay, also you can use beta hydroxy pentanol. Now the fourth product is when propanol is forming, propanol is forming a carbanion. What happens? As we can see, OH minus is going to abstract the alpha carbon hydrogen. So it is abstracting and we have formed that carbanion, which is going to attack a different aldehyde molecule this time. Different aldehyde molecule, so it's ethanol. So ethanol I have written. So ethanol molecule I have just written over here in the product side also. CH3, CO minus, as you can get hit here. And now H comes downwards. This C, particularly this C, is going to attack the carbonyl carbon, and it has made it its way. So next comes our CH3, which is written over here, and our aldehyde. So we got the product as 3-hydroxy-2-methyl-butanol. Okay. And in the case of Cannizzaro reaction also we will see. So in the case of crossed Cannizzaro reaction, what happens is, this is between two same kind of aldehyde I will show you, and then I will show you with two different aldehydes having no alpha hydrogens. That's our crossed Cannizzaro, two different aldehydes. Okay. So between two same aldehydes, generally what happens is, the strong base, here you have to use a strong base, unlike the aldol condensation where you have used a dilute base. The strong base NaOH only you can use, but what happens is in the step 1 you can see that OH minus is going to attack the aldehyde's carbonyl carbon, forming a hydroxy alkoxide ion. We can shift electrons, you can see it here. Okay. Now this hydroxy alkoxide ion is now making its way as hydride ion donor, but it will just donate H minus to another aldehyde molecule, another same aldehyde molecule, and you can just see over here H is moving towards this side. Simultaneous shift of electrons, because carbon is then having 5 bonds, it's already having 4 bonds here. Now when H will also join and attack to the carbon, so it will have 5 bonds, so it has to shift the shared pair of electrons, pi electrons between carbon and oxygen. So that's the shifting is taking place. Now what happens is, this also has to maintain its bonding, and so the negative charge is forming the shared pair of electrons over here. So we got from here, from this molecule, we got this acid molecule, so we got benzoic acid, and the next is like, this is the next molecule, this molecule. Okay, so C6H5 we got, CO minus we got, and 2H, because this was the H which was already present, and this H has also come and attacked over here. Now through proton exchange what happens is, this H is coming and it's joining over here. So this is our product. So this is our alcohol, right? C6CH2OH, benzyl alcohol. The other one, it's remaining like O minus, and it is abstracting, later on it is abstracting Na, taking on Na, and it is forming sodium salt of carboxylic acid and an alcohol. So from two molecules of benzaldehyde, what we are seeing is, one is getting oxidized to acid. This is also acid, sodium salt of carboxylic acid, as you have C double bond O group here, and the other aldehyde molecule is reduced to alcohol, as you can see OH group over here. Okay. Now when it's not the same aldehyde, both the molecules are not the same, then you have crossed Cannizzaro reaction. That's it. Okay. Now what we are going to take is, we will take formaldehyde as an example and benzaldehyde as an example. Now if you want to understand that which one will take part in the first step, where the OH minus is going to attack, then you must understand that amongst the formaldehyde and benzaldehyde. Formaldehyde's carbonyl carbon is more susceptible to the nucleophilic attack. That is, OH minus is our nucleophile. Nucleophile, that is nucleus loving, because it's negative charge, it's looking for positive centers. So it will choose formaldehyde prior to our benzaldehyde. Okay. Then it's going to attack over here, as you have seen in the step 1 also. And there is a shifting of electrons, so O minus over here, right? OH has been added up. Next, you are seeing the hydride ion transfer to the carbonyl carbon of another completely different aldehyde having no alpha hydrogen. Okay. Now there is again shifting of electrons, so you get it in this way, right? This molecule you have got it in this way, as it has taken another H over here. Okay. And simultaneously there was a shift of electrons here, forming the double bond, so you got it here. Now again there will be a proton exchange, and simultaneously you will get two products. One is oxidized product, that is sodium salt of carboxylic acid will be formed, and the other one is reduced product, which is our alcohol. Okay.